discussing the triangle law of vector addition followed by the parallelogram law of vector addition. Please note that both these laws are extremely important. We shall also discuss the concept of subtraction of a vector and the various properties of vector addition. Like, we'll discuss that vector addition is commutative and associative. We shall also discuss the various questions based on these concepts. So let's begin.
Okay, so the next topic that we have is the triangle law of vector addition, and in fact this topic is extremely important from your examination point of view because this concept is generally used in majority of the questions, right? So let us discuss this law. Given two vectors A and B, their sum or resultant written as A plus B, their sum or resultant is written as A plus B, vector A plus vector B. If A and B are represented in magnitude and direction by two sides OP and OQ of triangle OPQ, you can see here this is vector A, this is vector B, this is vector B, then their resultant is represented by the third side of this triangle, that is OQ, or you can say this OQ is the resultant of vector A, that is OP, and PQ. See, this is forming a triangle. That is also why it's called a triangle law of vector addition. So if you are supposed to add up two vectors A and B, where this is A, this is B, suppose, then the addition or the resultant of vector A and B is represented by this. You can call it C. So this is vector A, this is vector B, this will represent your vector A plus vector B, or sum of vectors A and B. What about magnitude of R? We are calling this the resultant of addition of A and B vectors, right? So if I call this R, then magnitude of R would be equal to under root of A square plus B square plus 2AB cos theta. Just remember this. In fact, you won't have to mug up this, cram up this formula, because once you solve out 2 or 3 questions based on this concept, this will automatically get fit into your mind, right? So the resultant R, magnitude of R, is equal to under root of A square plus B square plus 2AB cos theta, where theta is this angle. Now direction of R, let the resultant R make an angle beta with the direction of A. Then from right angled triangle QNO, what we can see is tan beta would be equal to QN by ON. Okay, so let us discuss this. Let the resultant R make an angle beta with the direction of A. That means if I take this angle to be beta, then from right angled triangle, this is QNO. From this right angled triangle, okay, let me clear up this so that you don't get confused. From the right angled triangle QNO, if I take this to be beta, then from right angled triangle QNO, tan beta, tan is perpendicular upon base, so that means I'll get QN upon ON. Now Qn, if I take as it is, On can again be split up into OP plus Pn. So I get On as OP plus Pn. Now Qn, this is my Qn. So from this triangle, if I consider this triangle, I can write Qn by B as sine theta. Sine theta is perpendicular upon hypotenuse. So perpendicular is my Qn, upon hypotenuse is B vector. So Qn by B is sine theta. So Qn becomes B sine theta. So I get it as B sine theta by OP is vector A plus Pn. Now again Pn, again from this triangle, if you consider Pn upon B vector, that will be cos theta, and therefore I get it as B cos theta. So this is what we get. Tan beta is B sine theta by A plus B cos theta. Again, these formulae prove helpful in solving questions, right?